Welcome to everybody, every students oriented to the Laurea Magistrale, so master course in Biomedical Engineering. As you know, this course is going to be held in English, so the official language is English, and the scope of this meeting right now is to introduce you to the courses that you can choose freely among the main available. It must be said that the series of course that we are going to present are have been selected among the two main routes of our course. One is more on the technological aspects, so artificial organs, medical devices, and the other one is on more oriented to clinical engineering and signal processing. This is a very general subdivision of the course, so you're free to choose the course among the other. The first one is going to be held officially by myself. I'm going to share the screen. You should see, yeah, the program right now, but indeed the course has been is still not official, but has been held by to Dr. Paolo Fattori. Paolo Fattori is the CEO of a very important company set in San Marino, so not far from here. We already have some very interesting collaboration and master thesis with them, and he's an expert on medical device and certification regulation. This is really a new course. It's new for this faculty, and indeed is pretty new in the national and international panorama. That means that these skills, the skills that will come from this course, are particularly required by companies because of the new regulation. I've been highlighting the main regulation for the North American market, mostly also Asian, so FDA regulation, but also from the European community union, which is absolutely new, is requiring very severe and intense activity of certification, and we have we have been very lucky to select Professor Fattori for this course. The content of the course will be about the certification of medical devices. In the more general vision, it could be also pharmacological devices as well as real hardware components. It will allow us to follow the process on this area, taking into consideration the quality aspect, the ISO 13485, the risk management, which is also a very important aspect, which is often kept aside during the official courses for time reasons. So it will be strictly within the aim of this course, and the ethical committees and post-market surveillance, which is totally new or mostly new for many medical devices. So it's very much linked to the medical devices, the course that have been introduced in the Laurea Triennale and master courses, and it will give skills and ability directly to be implemented in the industry as soon as the students will become an engineer, biomedical engineer, and eventually work in that area. Professor Fattori will be officially named as the reference for this course by November, so really in few weeks. For any question, you can contact me, and I will readdress you to Professor Fattori. I don't take any more time because, of course, this is very interesting, but we are a bit late respect to the time scheduling. So I would suggest that Professor Baldi, I don't know if Marco is connected right now. He was having his class. Yes, I see. And I want to thank you because you stopped make a break during your class and have the time for us. So please, Marco, the floor is yours.
Okay, thank you, Lorenzo. Indeed, I am giving a lecture of this course, so students are during their break. And I will be short also for this reason. You shall see my slides. Okay, yes. This is the name of the course, Biomedical Data Protection. Here you may find also my coordinates. I will be very short in giving a brief motivation for this course. Basically, we know what biomedical data are, like, for example, medical imaging, laboratory results, examinations, inpatient health monitoring. But today, we also generate a lot of biomedical data ourselves, like patient-generated health data through our apps, monitoring tools, smart watches, and so on and so forth. And biomedical data are personal data. And unfortunately, the amount of biomedical data is increasing very rapidly, and sometimes without control. According to these estimations, in 2020, we reached more than 2,000 exabytes of biomedical data. And in a time in which all data centers around the world were able to store about less than 1,000 exabytes. So the amount of biomedical data was already exceeding the storage power of all data centers online. And the main concern is about privacy, obviously, because estimations tell us that the amount of biomedical data is increasing and they need to be protected. They are increasing more than manufacturing data, than financial service data, even more than media and entertainment data. And obviously, privacy becomes imperative. These are some examples of cyber attacks to hospitals worldwide with very serious consequences of making them unable to operate their normal functioning. We may think that these kind of things occur abroad, mostly in the US or abroad, but unfortunately there were cases next to us as well. For example, here there are two pieces of newspapers about the Iesi Hospital, which was the target of a cyber attack some years ago. And the case of Regione Lazio this summer is another big and important example. So these are the basic motivations of this course. Last year, a case in Germany was even reported, which apparently caused one patient to die upon a cyber attack. So I firmly believe that a biomedical engineer today should know about data protection and how to apply data protection techniques to biomedical systems. For this reason, we proposed this course of 6 credits, 48 hours, in the area of telecommunications. This is in the first semester of the second year of the biomedical degree, and this is the program. We start with some introductions to cryptography and privacy. We speak about regulations like GDPR, and then we study some cryptographic primitives that are the main tools for protecting data. Then we go into protocols for security and data protections like authentication, network security, and so on and so forth. And then we also speak about some innovative technologies like blockchain and distributed ledger technology that is apparently interesting in the area of biomedical engineering as well. This is a very quick overview of the course. Obviously, I'm available for replying to questions or doubts, so please don't hesitate to ask me when you want. That's all.
Thank you very much, Marco. Thank you for your flexibility and time for this meeting. I'm just confirming, as we have done in the first part of the meeting, that all the lecturers are available by email contact. At the end of this meeting, we will provide the list of the course, the lecturer, and the email for personal contact. But I invite all of you as the students to just simply knock on the door of our office, so meet us along the faculty, because the human contact, as we say, is the more important. Thank you, Marco, for your time. Unfortunately, we don't have Professor Palma with the Internet of Medical Things course. He had a necessity to for a meeting and cannot meet us. I invite Professor Mandolini, Marco Mandolini, to join us and share the screen. Good morning, Marco. The course is Methods and Tools for Biomedical Product Design. The floor is yours, Marco.
Okay, I'm gonna share my screen. I seized this opportunity to prepare a pre-recorded video, so I'm going to share the video. Just 1 second. Yes, I need to disconnect the. Okay. Can you see my screen?
We see the screen, and
now I'm going to start the
record. Okay.
So I can keep the 5 minutes of time.
Dear students, I'm Marco Mandolini, lecturer of the course Methods and Tools for Biomedical Product Design. In this slide, you can find my contact details. I want to present my course with some questions. First of all, have you ever thought about how is it possible to design a custom-made medical implant considering human needs, and how to generate the geometry of the orbital implant you can see in this slide? And furthermore, what are the methods that can be used, and which software tools? Secondly, how to design a custom-made medical product, and furthermore, how to digitize a human body, such as the foot, and how to take into account biomedical characteristics when designing a medical device, such as a custom-made insole. Well, and furthermore, how augmented reality and virtual prototyping can support surgeons or clinicians. For example, how surgical guides can be projected as holograms in specific head-mounted displays for cranium maxillofacial surgeries. How to evaluate the effects of medical devices on the human body. For example, what's the displacement and stress of a dental implant under a specific load? How periodontal ligaments behaves? There could be some problems with a long-term treatment. Well, this course wants to answer these questions by providing you with methods and tools. Here, you can see the 4 main topics I propose to you during the lessons. Each block consists of theoretical background and practical exercises. Concerning medical product design, I will present you the product development process, the product design process, and design theories and methods in this section. In this part, I will show some design methods such as treats, functional analysis, morphological chart, quality function deployment, Moscow prioritization, and many other methods. I will conclude this part by asking you to design a medical device following the systematic product design approach. The second part will be the most important. I will present you the theoretical background about virtual prototyping, physical prototyping, solid modeling, surface modeling, and 3D computer-aided design system and augmented reality applications in medicine. I will spend some lessons presenting you the software and devices we will use for practical exercises. The systems will be Solid Edge, Rhinoceros 3D, Microsoft HoloLens, and NetFab. The case studies we will use to practice will consist in, for example, reconstruct the 3D geometry of a tibia and femur from CT images, design and position an implant, design an orbital implant, and design a custom-made mold for shaping an orbital implant. The following section deals with reverse engineering. I will show you 3D scanning systems, the reverse engineering approach, and how to model the 3D geometry from a points cloud. You will have the possibility to use 3D scanners and related software tools for two specific case studies. The first will consist in digitizing a 3D printed mandible, and the second in rebuilding the geometry of a femorhead. At last, I will present you the finite element analysis approach and related steps. Then we will use ANSYS to analyze a temporomandibular joint and the effects of mandibular advancement devices in patients suffering from obstructive sleep apnea syndrome. We can appreciate the impact of these devices on teeth, periodontal ligaments, mandible, and maxilla. I will focus the attention on the interpretation of the results. In the end, I will invite a biomedical engineer to give you a seminar to present how the topics you will have seen in this course are used in a real scenario. That's all. Please don't hesitate to call me or write me for any further information. Goodbye.
Thank you, Marco. It's really very, very interesting. I remind all of you that the video of this meeting will be available. It will be made available by Greta, but also possibly this video introducing the course will be also available. So this information will be shared also for the future. I forgot to tell you that we have, respect to the official program, the contribution by Professoressa Gesuita, Medical Statistics, is going to come as the last contribution of the day. In the meantime, I invite Professor Moglie with the course Electromagnetic Safety in Medical Devices to share the screen. Good morning, Franco. And if you are ready.
Thank you for your presentation. And now I'm going to share my screen. I think you can see the presentation. Please confirm.
Yes, we do.
Okay, thank you. And so thank you for your presentation again, and thank you to Greta to organize this workshop. Is very interesting for the student, and and now is a full screen. Give you an update on my computer, and so this course is a 6 credits course. I'm sorry for the mistake. Is a 48 hours, and this is the first year and the second semester of for the master degree of biomedical engineering. So it will begin at the end of February, or better at the beginning of next March. The exam will be oral, and so I don't have a right test, and the exam session will be not uniformly distributed on the year. I respecting the request for the dean of the university, but I will set more session at the end of the course, so the students are advantages to follow the course and after to have the exam at the end of the course. And so it's all the notes, all the material, like all the other exams, will be available on the Moodle website of the university, Moodle or Learner website. It's going in two ways. If I have to register to also to use the remote lectures, I will record it, and I will be uploaded in the same website. The scientific sector of this course is the electromagnetic field, and or electromagnetics is better to say in English. And there is also a non-homogeneity between the course of the first semester and the second semester. The students the students can follow the first lectures of the course in the first semester, and after they can choose this course because the deadline for choosing this course is, I think, at the beginning of November. It's not possible for the course of the second semester, and I suggested to the student, to Greta, to the other one, to ask to don't pay the fine for light selection of the course of the second semester, to have an homogeneity between all the courses of the university. If it's not possible, you can follow this part. It's just a few minutes. You can find the information on the syllabus, but also you can ask to the student of the previous year. And so I report the number of students who choose this course in the previous years, and how many students passed the exam. What is the advantages and disadvantages of this course? I would like to present an advantage, why the student can select this course, and what is a disadvantage. The main advantage, I think, is that the electrical and electromagnetic safety is not an interest for an university course, but it's an interest for all the population. In our home, our parents, our brothers, also if they are studying in the university, they know the problems related to the electrical safety, and also the electromagnetic safety, in particular in this period. We know how the people is scared from the 5G and for the mobile communication is in interest of a general population. A disadvantage is maybe that the topic of this course is very wide and complex, and perhaps 40 hours for the lecture are not too much to cover all this part. If you are going to work in the future work, if you are interested in this topic, maybe you have to do an additional training on this part. And what are the program? The program is well described in the syllabus. It's just I summarized it in the two parts: electrical safety and electromagnetic safety. The electrical safety is the safety of industrial power supply, and so I will present how to find the hazards for the electrical point of view, the effect of the current in the human body, and the protection. There is another thing in the case of the medical case in the hospital. The hazards are different. They are more hazard for the patient, and so this part is well detailed, and part of international regulation, international standard, we presented, and also the difference between Europe, North America, and the rest of the world, because the standards are different. For the point of view of the electromagnetic safety, I will introduce the electrical properties, the electrical simulation of the human tissues, and also I will present the part of the safety regarding all the electromagnetic spectrum from the highest frequency, so for the laser safety, and to the lower frequency that are
We're running out of time, so please go to the last point of the program, please.
Okay. Okay. Now is the last presentation, and there is the first part. The first part is the electromagnetic compatibility. There is in the hospital, in the medical environment, there is many electrical and electromagnetic devices, and these devices are to work together, and a part of electromagnetic compatibility will be done. And the compatibility with the COVID-19 pandemic, I hope to introduce to do again the laboratory practices in this year, and that was suspended for the last 2 years.
Yeah, thank you very much. That was really a problem the last 2 years. The opportunity to come in our labs and having a live session in the labs. Luckily, at the moment, seems that with some attention, it will be possible. So we all hope that the situation will get better and better. Marco Farina, Professor Farina is the lecturer of the course Fields and Waves in Biomedical Systems. So Marco, please, it would be very nice to hear from you about the course.
Thank you, Lorenzo. My course is Field and Waves in Biomedical Systems, as you said. The near half of the course will be laboratory. Students can do the exam, which is only oral exam, all over the year. Just be able to agree with me. So absolutely easy to make the exam. What is the topic? You know what is a field? It means that simply you assign a number to any point of space. In this case, it is a field. If you have more than one number, it is a vector field. Okay. If a field is perturbed, you can have a propagation of a wave. In this course, we are interested in different kind of waves. Elastic, electromagnetic, quantum mechanical. Okay. Of course, we will focus. We will start from the electromagnetic ones because I am an electromagnetic professor. But then we will cover the other waves. Why they are important in biology? They are important in 3 points of view. They are important because they can arise naturally in biological systems. You can have electrical signals, elastic signals between cells also, and you can have also probably quantum mechanical waves. This is something that is still speculative. We can use the waves to probe the biomedical system, so you can make an echographic investigation, nuclear magnetic resonance, microscopy, and so on. And moreover, they can be used for some kind of therapeutic approaches. So you can see, for example, about where the waves arise. For example, you can have cortical spreading depression waves, which are physiological wave of hyperactivity and lower activity of the neurons of the brain, appearing, for example, in transient ischemic attacks or even in aura in migraine. You can have elastic waves across your blood vessels, so that if you study the propagation of those waves, you can be enabled to measure, you can be enabled to measure pressure and other characteristics of the blood. These parameters change, of course, with the age. You can exploit the fact that, for example, bacteria vibrate when they are alive. So you can detect this tiny vibration, for example, in elastic measurement, and use this to make a fast antibiogram to understand when a bacterium dead or survive to some antibiotic. You can use you can measure electromagnetic waves that, for example, appears in brain that has a response of a different activity of the brain. So when sleeping and when being awake, when solving problems. So you have several kind of ways that appears. Actually, they can be used also, I said, as a therapeutic approaches. So for example, recently there have been several works discussing what happens in Alzheimer brain, okay, where somehow seems that the gamma waves are much depressed. So you can try to induce the gamma waves in the brain to make a kind of clock and enable the brain to work properly. I mean, in this case, it's a case where you can use waves to therapeutic approach. And finally, I said that we can use waves to investigate matter, biological matter, and so on. We will dedicate a lot of space to the microscopy, since our group invented some kind of new microscopes using electromagnetic microwave to probe the biological systems. So it will be a very interdisciplinary course. Being a short course, at the end we will not have time to discuss any single part, but being a standalone course, we can agree with the students which part is more interesting for them when discussing the waves. I'm always available for questions.
Thank you very much, Marco. As we have stressed all along this meeting, there is the warm invitation to all of our students to keep in contact even if they have only a feeling of something interesting or have any curiosity, to get in contact with the lecturer and trying to understand better. I didn't say, but as you have been easily imaging, all these fields, especially the new one, especially for the one for Laurea Magistrale master course, are also very often the topic of the thesis or the internship within our laboratories. So interest could arise also for this reason. I invite Professoressa Lucchetti, Liana Lucchetti, with Bionano technology to share. I don't know if you, Liana, have slides or want to.
No, I'm here in person at the end.
Which is very, very, very good. So the floor is yours. Thank you.
Okay, good morning, everybody. I will try to share the screen. Okay. Can you see it?
Yeah, we do.
Okay. So I will just give you a brief presentation of the course. The name is Bionano Technology. This is my email address if you are interested in asking me some question. And this is a course of 24 hours, so you will have 4 hours per week of class, typically 2 and 2. Okay, so just to give you a brief outline, the course, of course, is based on Bionano technology, which is a discipline in which tools from nanotechnology are used to study biological phenomena. Just to give you an example, nanoparticles, such as quantum dots or polymeric nanoparticles, can be used as probes, as sensors or vehicles for biomolecules or drugs in cellular systems. Okay, since the first issue related to bionanotechnology is to be able to see things at the possibly at the nanoscale, at the microscale, and possibly at the nanoscale, the first modulus of the class will be devoted to the technique which is commonly used to image things especially biological systems. So we will speak about optics, so the basics of the interaction between light and matter. We will speak about the resolution. We will see why the resolution in conventional optical microscopes is limited. And we will see that it is possible to overcome these limits. So there exist several super resolve techniques which are based on the use of different signals with respect on light, or are based on some tricks in order to overcome the resolution limits. So we will speak about conventional microscopy, fluorescence microscopy, confocal microscopy, and so on. And then we will have a look to electron microscopy, atomic force microscopy, scanning near field optical microscopy, simulated emission depletion microscopy. So several techniques. And during this, and during these first modules, we will also have several visits in several labs to see several of these techniques. For example, we will go to visit a lab with a fluorescent microscope, one with a confocal microscope. We will see the atomic force microscope of Professor Farina, who is very nice. He allows me to bring students, and also the electron microscope. So we will have several visits. Then we will have another modulus based again on what we can do with light. So we will speak about optical tweezers, which is a way to manipulate microscopic objects without mechanically touching them. So it is very useful for manipulating biological systems. We will speak about optogenetics, which is a way of controlling the neuron activity using light. And okay, to understand all these things, we will have also to introduce the principle of operations of lasers. Then we will have a third module based on microfluidics. So we will speak about microfluidics with also some basics of the dynamics of fluid in these micro dimensions. So we will speak about the Navier-Stokes equation and things like this. We will speak about which are the micromechanical technology which allows to use microfluidics. We will speak about, of course, also digital microfluidics, which is the one in which your fluid is in droplets, which is very useful in the field of bionanotechnology and very used in the field of bionanotechnology. And we will also speak about optofluidics and electrowetting, which is a way to control the shape of the droplets with an electric field, which is also very useful and very, it is a technique widely used nowadays in the field of digital microfluidics and in the field of microfluidics of biofriendly materials. Then we will speak about nanoparticles. So we will mention several kinds of nanoparticles, such as metallic nanoparticles, nanomagnetic nanoparticles, polymeric nanoparticles, quantum dots, and so on. And for each of them, we will see which are their applications, of course, in the field of bionanotechnology. So just to give you an example, nanomagnetic nanoparticles are widely used in magnetic resonance imaging. So we will also introduce this technique. At the end, we will speak about biosensors, of course, all the kind of biosensors that we can think about, so the label and the label-free biosensors, with a special attention to the optical biosensors, so those where all the information come from the interaction between light and the things that we want to sense. So we will do several examples, mentioning also the techniques that are commonly used in these optical biosensors. So, for example, surface plasma resonance, depolarized fluorescence, or sensors based on liquid crystals. So we will have, I think, a wide overview about these techniques. By the end of the course, there will be also a couple of visits in our labs, in which you will see an optical tweezer setup and several examples of applications. You will see a setup to measure the weight and behavior of specific bio-friendly and novel materials, so you can have an idea of also what we do in our lab. Just to mention, maybe you are interested in knowing that the collaboration that are at the moment active in our lab and that are related to some of the topics that I will speak about during the classes, for example, optical tweezers or study of the wetting behavior, are with two research groups in the US, which are very well known, and two research groups in Italy. One, it is in the Department of Physics in Padua, and the other one is in the Faculty of Medicine of the University of Milano, and in particular this Department of Biotechnologies and Translational Medicine. I finish. Maybe I've been very fast, maybe too fast, I don't know. Should you have any question, you can contact me by email whenever you want. And you can also, I think, contact the students that are attending now the class or attended in the last year, just to have some advice or some impression. I have more or less between 12 and 15 students per year, and this is the third year that I'm giving these lectures.
Thank you very much. Suggestion is extremely interesting. I didn't stress this up. There is also very important inter-students exchange of opinion and vision on the course that could be put in as a contribution to this discussion. So you can have the official content and the deepening of the course with the lecturers, but also having a feedback by the other students regarding the content and the modalities of the course. I don't want to take too much time, and I want to thank Professoressa Gesuita. I'm sorry I wasn't able to keep strictly in time, but being in Italy, would say that 9 minutes is almost a miracle on scheduling. So
I agree with you.
Apologize me for this bit of delay. I just want to stress the fact that Professoressa Gesuita is giving us the help from the medical school of our university. So she has a very deep knowledge about the medical statistics. That's the reason for the course. And then Rosaria, this is your time. Thank you.
Okay, thank you. I share the screen. Can you see the slide?
Yes, we do.
Okay. Thank you. First of all, thank you for the opportunity to present the course of medical statistics. There are these that you can see. Okay, thank you. These are some of many possible questions related to human health, with health in human population. The answer are not deterministic, and every aspect, because every aspect connected to human health must be considered as a stochastic process. The answers are obtained through observational studies and clinical trials that follows an observational or an experimental approach. Medical statistics is the science of studying health phenomena in human populations by assembling data in many fields, for instance, in medicine. And also by analyzing the phenomena using a quantitative approach, because phenomena tend to vary in the populations. Just for an example, phenomena may be simple, such as evaluating a temporal trend of a chronic disease like diabetes in the world, and collecting and analyzing the data, we can observe that this pathology is increasing dramatically over time. And we also, we can also observe that diabetes is characterized by a high variability in the distribution of the frequency of the disease in the world or among people. And so when we have observed this variability, we want to know why the number of people with diabetes increases over time, why diabetes is so heterogeneously distributed, and the study of the phenomena becomes more and more complicated, but also more and more interesting. Medical statistics provides a set of methodology and procedure that make it possible to manage and process the information collected on individuals. And in this way, medical statistics is crucial to obtain scientific evidence in medicine. These are the topics proposed for this course. Medical statistics is a very wide-ranging subject covering a very large number of topics. In this course, I will introduce the underlying concepts of medical statistics, and I will discuss the most commonly used statistical procedure, both in medicine and in biology, and the way of data management. And you will learn to perform statistical analysis on real data that has been collected, for epidemiologic purposes, and you will learn to use the statistical software R, which is very free, and very powerful. I believe that it is important for students to be able to use computer packages for analyzing biomedical data and to interpret their output. The assessment of a student learning will be consist of solving a practical test using the statistical software R to evaluate the ability of the students in analyzing data and in the interpretation of the obtained results. Okay, I finished this presentation. I hope to have been clear enough, and I remain to your disposal for any questions.
Thank you very much, Rosaria. Everything was very clear, at least to my eye. I will leave to Greta and eventually to anyone else participating, meaning particularly the students, if they need any clarification or have any questions. I still see most of the lecturer and professor still connected, so able to answer. So that's your time, dear students, to put your questions or request of clarification. Okay, seems that we were pretty good in presenting our course. I just want to close this part remembering that the list of the courses, lecturers, and email address will be made available by Greta Di Marino through the same channel that has been used for this event. I want to apologize with colleagues if I was a bit stressing with time and scheduling, but the purpose was to keep everything within the 2 hours so the students can move along the corridor or virtual corridor of our faculties. And please remember also that the recording of this event will be made available too. So if anyone has some comments in this regards, please let Greta knows, and then they most probably will cut if we don't agree, or some of us don't agree. Sincerely seems that we all agree, but if there is any opposition, please let Greta knows it. Greta, your time.
Okay, stop the record.